Today I want to talk about series, parallel, and series parallel circuits, and I'm just going to give a brief explanation of what they are. So let's start with a series circuit. So a series circuit has one path for current to flow. So these are resistors. They could be motors, they could be light bulbs, they could be anything. But there is only one path for current to flow. Series circuits have four rules that apply to solving these series circuits. The first one that defines it is there's only one path for current to flow. And in another segment, we'll talk about how to solve series circuits using Ohm's law. But to understand the rules, you have to understand the circuits. The other circuit that we deal with primarily is the parallel circuit. So let's get rid of that. In a parallel circuit, all resistances feel source voltage. So our source is 12 volts. Oops, that's not correct. That's a series parallel. There we go. Okay. Now we got it correct. So all our resistances feel the 12 volts. We'll get 12 volts here, we'll get 12 volts here. That is the definition of a parallel circuit. If I was to put a resistor in here, like I originally had, now only this one's going to feel 12 volts. There will be a voltage drop to these two. So this is a series parallel circuit. Being able to define the difference between a series, a parallel, and a series parallel is the first step in solving circuit problems. Now, the parallel circuit has a set of 6 rules that apply to solving all resistances, amperage, flow, power, anything in a circuit you need to do. Series has 4, parallel has 6, and series parallel is a function of breaking the circuit down. So it doesn't actually have its own rules. What we have to realize is there will be a voltage drop here. We're not sure what it is at this point, but it's going to be less than, so 12 volts may be dropped here, or I'm sorry, 6 volts may be dropped here, which means there's 6 volts here and here. So this part is acting like a series, and this part is acting like a parallel.